Hello and welcome to the lab. In this video, I'd like to share how easy it is to start a print on the Markforged X7. The first thing we'll look at are the different parts of the printer to be familiar with. The printer has a clear cover in the front that has a slot for your finger up here to move it up and down. The printer also has a cover up here to which we can access the extruder and motion system, which I have to kind of get a ladder for. This is where we will be double checking that the material is fed in properly. A nice feature is that it's soft close. Down here is where we store our filament while printing. The cabinet doors are push to release. Inside here, the main component is this dry box. This dry box is crucial to, as you might have guessed, keeping our filament dry, which is super important for getting accurate prints and good bed adhesion. This dry box has two latches on the side, and the best rule of thumb is to keep this dry box open for the least amount of time possible. Your 15 minutes can be used as a benchmark. Don't leave this dry box open for more than 15 minutes. Here is my onyx material within the dry box. Quickly take it out for you. It looks like this. It's on this magnetic spool holder. That makes it really easy to load up the filament back into the dry box. And the spool holder rotates, of course, to make it easier when we print. When you close the dry box, you want to make sure you hear very loud clicks from both of the latches. Okay, on the side here we have the USB port for loading in our files. With the typical Markforged printers, you can use their Eiger.io slicer to, over Wi-Fi, send your files to the printer. Unfortunately, this printer is sitting on university grounds, and that means wireless control is very difficult to achieve without road bumps. That being said, our power went out recently, and the linked connection we had doesn't work anymore. So we're just loading our file via USB today. If we open this plastic hood, we can take a look inside of the printer. Inside, we have our extruder head that has two nozzles, one for the actual filament and another for the continuous fiber inlays. Also on this head, we have a laser module. This laser is used for quick bed leveling on our printer, and that's very useful. Here we have our bed carriage, and our bed sits on top just like this. Super easy to locate, also magnetic. If I lift it, we can see there's 3 points of contact to locate our bed. Nice. Over here we have two storage spools for storing our continuous fibers. Currently we have fiberglass stored on this side and carbon fiber loaded into the printer. There's a small tube on this side that actually goes all the way to the extruder head. We have yet to try this, and when we do, I'll make another video on that. Another key feature here is the touch screen that allows us to navigate through loading material, leveling the bed, and so forth. The touch screen is probably the worst part about this printer. If you touch and hold for too long, it tends to skip through things in the settings. Using a stylus is really helpful. Let's explore the motion system of the printer. Welcome to the top side of the Markforged X7. It's belt-driven, features linear rails, and this is where we track through these two PTFE tubes whether the fiber inlay is loaded or the filament is loaded. As you can see, there's no filament currently loaded in this printer, which is our next step before starting our print. One thing to keep in mind is how much you use this printer. For example, you don't want to keep your filament loaded in the machine if the machine will be staying idle for more than, I would say, half a day to a day. The problem is moisture can creep through the filament and then through the rest of the spool by leaving it loaded in the printer. Particularly, there's an access hole back here that connects the PTFE tube to the filament, dry box, and to the extruder head. So if your printer will be staying idle, it's a good idea to unload your filament and then plug the back of the dry box to minimize how much moisture will enter the filament while the printer is not in use. Welcome to the back of the Markforged. I'm using my phone flashlight to show you this red plug is something that comes with your printer and is used to plug the back of the dry box to again minimize how much moisture gets in there. So when you're ready to load your filament again, you want to remove this plug and connect the PTFE tube that goes to the extruder head. So that's what we're going to do. Like most of the printers we're familiar with, it's just a push and pull kind of quick release, and the PTFE tube just fits inside. And then we just do a little check to make sure that it's in there tightly. Great. Following the PTFE tube up to the top of the printer, there is a hole in the frame with a little gasket O-ring thing that guides the top of the PTFE into the rest of the system. Now that I've set up the dry box and PTFE tube to be ready for material loading, I'm going to go ahead and select the material load plastic utility so that our nozzle can heat up. We have a warning here that says, please make sure your dry box is latched at the end of this utility. Wet plastic is a leading cause of print failures, and the plastic will absorb significant moisture when exposed to air for more than 15 minutes. As the loading utility is running, you're going to need to feed the filament in through the dry box hole and up to the extruder. So I've just undone the filament from the spool, and I'll snip off the kinked piece from that and then feed this into the back of the dry box. As you're pushing the filament up, you should see it start to appear into the PTFE tube. The drive is running right here. It should latch on to the filament and guide it through the rest of the PTFE tube into the hot end. Lift the top. You can also check through the tube. It should be guiding through the drive here all the way to the hot end. The printer will start extruding it through the nozzle, and then in the utility you can hit stop. Once you've seen the filament extruding out of the nozzle and you hit stop, the utility brings this screen, and then you can just hit done. This would be the perfect time to make sure that your dry box is fully closed by just latching the two clips and closing the front. To make sure we have the proper height between the nozzles and the build plate, the Markforged printer comes with two metal shims that we'll use for calibration. They're both labeled, so the one used for the plastic nozzle says plastic shim, and the one used for the fiber nozzle says fiber shim. As we're calibrating the plastic nozzle, we will be using the plastic shim. The utility reads, slide the plastic shim between the print bed and the plastic nozzle. Nudge the bed up and down until you feel slight resistance when sliding the shim. Do not adjust the thumb screws any further. So by thumb screws, there's these 3 thumb screws underneath the bed. These are used for initial adjusting. As we saw, we had a red, green, red scale when we did the initial laser bed leveling. The thumb screws are only used during that part of the utility, and moving forward we use the shim. If you've used a 3D printer before with manual bed leveling, you'd be familiar with the paper trick that we use to level our bed. The shim here is following the same idea. So I've just fit the shim under the nozzle, and I feel slight resistance between the shim and the nozzle. I have calibrated this machine before, so I'm happy with this gap distance and will continue through the utility. Next, we will repeat the exact same thing with the fiber shim to make sure the fiber nozzle and the gap between the bed is to our standard. There is an exposed 2.5mm Allen head screw at the top of the print head to adjust the height of the fiber nozzle, and we do that until we can feel a slight resistance between the nozzle and that fiber shim. This is the cap screw in question, right next to where the fiber gets loaded into the print head. Once you're done calibrating, you can hit next. There is a fiber nozzle height calibration utility that is a small print that basically wipes the fiber nozzle over your print to see if there's any collisions. I will be skipping this utility for this video, but it is highly recommended that you do run it, especially if you plan on actually using the continuous fiber inlays in your print, where it really does matter what your gap distance is between that fiber nozzle and the build plate, because the last thing you want is for it to destroy your print. So I'm going to hit cancel after this, and the build plate lowers down into its starting position. All of the adjustments that I have made have been saved, even though I hit cancel, so I know my print bed is still calibrated. I'm gonna go ahead and hit done. Once I've loaded my filament and calibrated my printer, I'm now ready to start my print. Before doing so, I will cover the build plate with some glue so that it's easier to remove my print after it's built. We keep our glue in this little cabinet right here. The recommended glue stick by Markforged themselves is that purple Elmer's glue. So if you're not familiar, it starts purple, and then after you apply it to the build plate, it dries clear. So I'm going to go ahead and give a nice, even, thin coat to the build plate. Now, it may not be often that you find yourself printing the whole build plate's worth of volume, so you can go ahead and just apply glue in the area that you know your build will be in. And then also you want to make sure you have a strip of glue in the back here and in this area here. That is because the printer actually runs a purge line back here to basically purge any material that could have potentially absorbed moisture while it was still loaded in the printer. And it also lays some calibration beads here, to which it then uses the laser to inspect this calibration print and make any adjustments to make sure that the actual print turns out as expected. Now, I did mention earlier that we'll be using a USB and the USB port on the printer to load the file onto the machine, but if you're connected wirelessly through Eiger, which is the Markforged slicer, then you can skip this step. But to load my file, I've got this little USB. Just plug it into the port on the side here, and then select the proper file via the file utility on the printer screen. Once I've plugged in a USB, I'll have this little USB icon where the printer recognizes what I've just plugged in. So I can go ahead and hit the USB icon, and then I get 3 options: print from storage, print job history, and save logs. I want to print from storage. So here I have all of my print files that are of the proper .mfp file type saved on the USB. It shows up in multiple pages, so I'm just going to look through until I find my proper file. Go ahead and click on the file. The nice thing about this printer is that it actually copies the file from your USB onto the machine itself, so once it's done copying and validating the file, you can remove your USB from the printer. To prepare for this print, the machine will bed level and then heat up to the proper nozzle temperature. As I previously mentioned, before the start of your actual print, the machine runs this really thick deposition. It's an extremely wide bead. Get through any of the filament that could have potentially absorbed moisture while we were loading it or while it's been sitting. It's a similar idea as if you were to cut off like a meter of filament from your spool before printing. Hello, welcome back to the lab. Outfit change because it is a few days later. I do want to make a quick mention about how to unload your material to make sure it doesn't absorb any extra moisture after you're done printing. Once you open the front of the Markforged, you can access the touchscreen. If you hit the 3 bars at the top and then the materials utility, there's another utility to unload your plastic. What that will do is heat up the hot end. Then you will cut the material right after the direct drive unit up here. I'll show you close up and basically pull all the extra out. Then you just rewind the rest and store it in the dry box and plug that dry box from the back. The touchscreen, we hit the 3 bars at the top, hit materials, and then unload plastic. Immediately, the hot end will start heating up. Now that it's all hot, it's expelling unused filament through the hot end. Snips. What we need to do next is cut the material end so that we can pull the excess out. On the way into the direct drive, there's a quick release tube, so just push down on the black piece and the PTFE will come out. On this side, it's a screw, so just go ahead and unscrew this. Try and get the PTFE tube out. Snip on this side so the material goes through the extruder and we can pull the rest out. Sometimes you'll have to hit retry so that more material gets fed through the direct drive, but once the filament comes out of this end of the direct drive, you can pull it right out. Because the nozzle is still hot, it dislodges pretty easily. There we go. Once you've pulled out the material, you can go ahead and hit stop. Of course, you should reattach the PTFE tube so that everything goes to plan the next time you load material. Hitting next, it asks you if you've successfully unloaded your plastic. I don't want to load any new materials, so I'm going to hit skip, and I do want to cool down, to hit yes. Alright, now it is a matter of just respooling the filament in the dry box. And just open this dry box, basically keep coiling up until we get the end of the filament. And then using one of the holes on the spool, we can secure the end and snip any extra and quickly put that back into the dry box. Snap it shut. And then the very last step is to remove this PTFE tube that feeds into the dry box and plug it with this provided red plug. So it's another quick release. You just push down on it and you can pull out the tube and then just put this in that same hole. And that is what it should look like once you've plugged that dry box. And that completes the unloading material utility. So those are the basics for setting up a print on the Markforged X7 Industrial Series 3D printer. If you have any more specific questions, feel free to leave them in the comment section below. I'm also interested in doing some videos related to the continuous fiber inlays within prints, as well as any Eiger slicer tutorials. If you may be interested, again, let me know down below. I understand not everyone has access to a printer like this, so I think it's great to help people technically who do own it, but to kind of share the technology that is out there. Thank you for watching, and I'll catch you in the next one.